I'm going to demonstrate how to calibrate 3-point bore gauges using SANGHA Truecal system. SANGHA are the first people to make this type of instrument nearly 30 years ago. Many are in the field, and now due to some popular demand, we have introduced a bigger size going up from 150 to 300 millimeters. Prior model was basically up to from 16 to 200. So I will demonstrate how to calibrate 3-point bore gauges using the TC4 Truecal system, which we have introduced recently. First of all, before I start calibrating, I have developed a sheet, a process sheet for the procedure of calibrating. Now, these are the slip gauge sizes that we are going to use, and the nominal positions are these. Calculations of this can be shown in another sheet later on. Okay, so first of all, to actually we have to use this piece of packing to lift the slip blocks up. That's necessary because there are other makes. This is a blind bore measuring system, but there are other makes from Micrometer, Tesa, Mar, all these other people, where the angles are not blind bore reading, and they have a considerable length from the face to the actual measuring point. So with this method, we can actually lift the slips up. Okay, I'm going to use this as a standard. Right, first of all, we set the instrument using 50 millimeter slip block. As I mentioned in here, zero setting is carried out with 50 millimeter slip block. You can use any slip block, but that's the one that I've adopted, and this is what we will base our measurements on. So I simply slide the slider, which is basically forms a variable ring gauge, and I zero this at this point, zero it, and I just increase that's 2 millimeters, so we'll just do about I want to make it about 1 millimeter. Okay, so that's where zero is, I think. I'm going to now come out, measure 0.5 millimeter from bottom range. Okay. At this point, I'm going to set this instrument to zero, to read zero. I take a lot of care to make sure I get the correct zero. The way of getting the correct zero is to get a reversal, get the smallest possible reading that is possible. Okay, this is -4. Ignore the minus side, but it's actually 14 microns. Okay, that's 15 microns, 10 microns, 8 microns, that's 1 micron, that's 0. It should start getting, if I get a plus reading, in this case without the minus, I bring it to 0. Okay, now it should start getting minuses. Okay, it will keep on getting minus. As I'm moving this very small amounts of rotation, I'm getting a reversal. I'm looking for the reversal, which is a common thing for most laboratory people. So it shouldn't be difficult. Okay, I take this slip block out. The next slips that I've set in my plan is 47 millimeters, which will give me 2 millimeter nominal position from 0. Okay, 47, I simply build this up with 40 millimeter slip block and 7 millimeter slip block. Just ring it together. Ring the slip block so that it is flush with the top face. I put it onto the packing slip, which I showed earlier. Now I get my reversal on here again. Okay, smallest possible reading I can get. That's 1999. That's 2. It's gone up. 1999. And I can't get anything smaller than 199. Okay, 199 or 1998. This jumps up back to 1998. So I enter my result 1998. Here it's 0. At 2 millimeter from bottom end to the start of the range of the micrometer to 2 millimeters, I am getting 1.998. 1.998. Okay. I go to the next reading, which is 44. I simply take out the slip block, exchange the slip for 4, keep the slips clean so the ringing is easy. Once again, I take the slip block to the top face, pull the trigger, place the slip block on the look for a reversal. 3.998, 3.997. So go back again. 3.996, 3.996. That's 8. 3.996. So I enter my result in here. 3.996. Okay, I go to the next reading, which is 40 millimeters. I simply remove the 4 millimeter slip block. This is a 40 millimeter block. Insert this in place. And I once again look for the smallest possible reading. Six. It's giving me 6.666, which is basically 0. 6.666. Now go to the end reading. 35. I just simply take 30 millimeter slip block, 5 millimeter slip block, ring them together. Once again, make sure they're all flush on the top. Okay, this should give me 10 millimeter. 10. Just find once again, see how small I can get to. 9.999. Small increments rotationally will get you your reversal. 10.001, 9.999 is the smallest reading I've got. Okay, and then from this I can get my deviation, which is 0.00 minus 0.002. In this case is minus 0.004. In this case is 0, plus or minus. 10 is minus 0.001. Okay, so that's my results for this micrometer. Here is 0, set plus or minus 0. Okay, That's calibration complete. Thank you.